Okay, lesson 10.2 in accelerated math analysis is dealing with conic sections. We're going to start with parabolas. 10.1 is really just a section to read on your own, and it introduces the fact that we'll talk about parabolas, ellipses, circles, and hyperbolas. But a parabola, you can see at the top of our notes, is a locus of points or a collection of points that are the same distance from a fixed point F, which is called the focus, as they are from a fixed line D. F is the focus, like I said, the line D is the directrix. And as a result, a parabola is the set of points for which the distance from F to P equals the distance from P to D. Well, first thing I want to point out is that a parabola does not have to be opening up and down necessarily. It certainly can open left and right. And let's just say that we had an arbitrary point, which we could call P. Right here, that might be the point X comma Y. What we're seeing is that distance from point P to the focus should be equal to the distance from point P to this line called the directrix. Now, what we're going to identify here is that A is going to be positive, and we'll have a focus A comma 0. That's a point that we're going to have using this locus definition. The directrix will have a line. We'll make it a vertical line, the line x equals opposite of A. I've written the distance formula up here, and if we'd like to find the distance from point P to the focus, really we're going to say that we're going to have x2 minus x1. Let's call x2 our x here. X1 we could call A, and we'll square that. Y2 minus y1, we can have y minus 0, square that. That's your distance from any point on the parabola to the focus. But if we're measuring our distance from point P to a vertical line, we are going to travel our distance moving horizontally, left to right. In other words, the distance from point P to this line is this highlighted horizontal segment. And we'd have an x value that we are letting represent just some arbitrary value of x going to the line x equals negative a. Really, how far is it from x to opposite of a? Well, we can always do right minus left to find the distance of this segment. X minus negative a would be the way we can do that. So that's really going to turn into x plus a. Now, from here, I'm going to square both sides. And, y minus 0, of course, is just y squared. Here I'll have x plus a quantity squared. And very quickly, as I expand and square, we'll have x squared minus 2ax plus a squared plus our y squared here. Square on the right, we'll have x squared plus 2ax plus a squared. And just some canceling that we can immediately take care of. How about we subtract x squared from both sides? How about we subtract a squared from both sides? Simultaneously, we can add 2ax to the left and the right side, and we will come up with this. Y squared equals 4ax. You can see in this table that we have right here, if our vertex is going to be at 0, 0, and if we have a focus on the x-axis or on the y-axis, we're going to be able to come up with these very simple equations for a parabola. You're going to see that we just did number 1 here. We had a focus at a0. We have a directrix at x equals negative a. Our vertex is going to be right here at 0, 0. And this very simply would be opens right. Again, just redrawing that picture just for the sake of comparing all of these other parabolas. We've got this focus at a comma 0. We have this line x equals opposite a. And of course, we have our vertexes at 0, 0. I think it's very important for us to note, too, that A is the distance from the vertex to the focus. Similarly, we could also think of that as A is the distance from the vertex to the directrix. Both of these statements are true. So that's going to help us in the future. We're going to look at that A value, and you can see it's coming back up here to our original picture or the one that we just copied down. You can see our vertex is A steps away from the focus. Our vertex is A steps away from the directrix. And that's always going to be the case. That A is going to give us valuable information. You might wonder what happens when y squared equals negative 4ax. Well, this is when we are going to open left. This parabola opens left. So you can see that actually our focus now is going to be over here at negative a comma 0. Our vertex is still at 0, 0, but this time we'll have a directrix at x equals a. X equals positive a here. And we'll be just going in this direction. For number 3, finally we have a very different setup. X squared equals positive 4ay, and that's going to be a case where this opens up. So we can very quickly find our vertexes at 0, 0. Our focus will be at the point 0, comma a, a distance of a steps above the vertex. If we go a steps below the vertex, we'll have a horizontal line, and this would be the line y equals negative a. And of course, our parabola would look something like so. Last, we can see if x squared equals negative 4ay, this opens down. And again, x squared equals something negative. You're still going to have your vertex at 0, 0, but your focus is always a steps away from your vertex. Your directrix is a steps, in this case, above the vertex. It's a steps away. This would be y equals positive a, and we'd have a parabola that would look something like so. So here are those 4 general cases where your vertex is actually at the origin. Being able to quickly analyze and graph, let's say we had y squared equals positive 8x. If you have y squared, you know that you're either opening towards the left or towards the right. Because y squared is equal to something positive, we're going to open towards the right. Of course, this is a general form of 4ax on this right side. If 4a is equal to 8, the number in front of x is always 4a. That means a is 2. And you might wonder what that really means. Well, we're going to have our vertex at 0, 0. We know we're opening up towards the right. Something that you're going to notice is that your focus will always be on the interior of that parabola. It's going to be in the direction of where you're opening. So if I'm opening towards the right, my focus has to move to the right. I'm going to move 2 steps over here. My focus would be the point 2, comma 0. Likewise, my directrix will be 2 steps away from the vertex, moving towards the opposite direction, towards the left, and it's going to be a vertical line. So my directrix will be x equals negative 2. Now, it can be very helpful for us to know that each of these parabolas that I've just drawn up here has a very special segment that we can take a look at. The segment that passes through the focus has a very special name, and it's always going to have a length of 4a. it will always have a length of 4a if you draw that segment through the focus. The name of that is the lattice rectum, and the wonderful thing about having this information is that 4a is going to be split in half into 2a and 2a. So you're always going to have this symmetry that can be used to quickly help you graph. This is what I'm talking about. If we know that the lattice rectum length is 8 here, that we have a length of 8, if I were to cut 8 in half, I'd have 4. So what I could do very quickly is say I'll go 1, 2, 3, 4 steps above my vertex. I'll also go 4 steps below. And that will be 2 additional points that we can get on this vertex, on this parabola. I'm so sorry. What you can get, thankfully, also is just the peace of mind of knowing that you can graph so quickly. You'd have a 4, you'd have a 4 here. This point evidently is 2 comma 4. Down here is 2 comma negative 4. You can check that you have graphed this correctly. Plug in x equals 2. You should get y to equal 4 or negative 4, as you see on the lower point. So this property is going to allow us to graph very fast. Take a look at example 2. X squared equals negative 12y. And just want to point out this is a parabola that must open down. If negative 4a is equal to negative 12, you could say very quickly that a would have to equal 3. 3, this a value, is the distance that your vertex will be from your focus and also from your directrix. So let's very quickly make ourselves a picture. Here's our vertex at 0, 0. I know we're opening down because x squared always means open up or down. With the negative, we're going down. That means that I can move 3 steps below to get our focus. That's 0 comma negative 3. I can move 3 steps above to get my directrix. My directrix is a horizontal line. Horizontal lines always have y equals. So I'd have y equals 3. But here we go again. The lattice rectum should have a length of 12 because that's your 4a. Half of 12 is 6. So I'll go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 to the left also. Remember, this is going to help us as we would make a segment that would go through the focus. We'd have 6 this way and 6 this way. And of course, that's definitely going to help you out. You can double check that you've plotted this correctly by double checking your points. You should have 6 comma negative 3 and negative 6 comma negative 3. It would only take a moment to substitute these y values in and to confirm that your x values would also agree. So knowing information about the lattice rectum will help you tremendously. Let's move over to number 3. Find the equation of the parabola with a focus of negative 4 and a directrix of x equals 4. So it's not a bad thing to start by graphing. You can see real quickly our focus would be here at negative 4, 0. Looks like we have a directrix of x equals 4. It sure looks like we're opening towards the left. You might wonder how you know. Well, it's being familiar with these 4 pictures right here, knowing that your vertex is always right between. Your vertex here is going to have to be 0, 0, and your vertex is always going to open in the direction of the focus. You're opening up towards the left. So you'd have x squared, I'm sorry, not x squared, but y squared, because y squared always would open left or right. But when you're opening towards the left, you'd have negative 4ax. Hopefully you can see quickly that your a value then would have to be 4. If a is going to equal 4, quickly you can just substitute that in and quickly quickly see that y squared equals negative 16x.